of Microprocessor 8085, and in that lecture today we covered some content, that is the review of lecture number 4. Second content of this lecture is the information about the program status word, or it is also called as the flag register. So going to the first content, that is the review of lecture number 4. So in last lecture we covered some topic about the arithmetic and logical unit. Another topic which we are covered, that is related with the accumulator and their importance, and one more topic we are covered, that is the general purpose register. So just I revised that last lecture content. So in last lecture we knew about some general purpose register which are available with microprocessor 8085. So in MUP 8085 we are having the 6 8-bit general purpose registers, and the name of that registers are B, C, D, H and L. These registers are consist of 8 flip-flops, and the capacity is to store the 8-bit of information in that register. And if you want to store the 16-bit of information, we want to use the pair of that registers, and the pair of the registers are named as BC, DE and HL. These are called as general purpose register because these registers can be used by programmer at any time and anywhere in the program. So that's why it is called as the general purpose register. Another content which we are covered in the last lecture, that is the accumulator. Accumulator is also one of the registers. It is also consist of 8 flip-flops, that is also stored the 8-bit of information. But it is different from the general purpose register because it's having their own importance. And that importance is also we are studying in the previous lecture, and we are observing that whenever the microprocessor will perform the addition of two 8-bit numbers, at that time, after performing the addition of two 8-bit number, or whenever we are performing the addition, we require the two numbers, and from that two numbers always the first number is present in the accumulator. After addition of this two 8-bit number, whatever be the results you are getting, that result is also stored in the accumulator itself. That's why this accumulator having their special importance, and it is away from their general purpose register. Going to the another content of previous lecture, that is the information about the arithmetic and logical unit. We are performing the different arithmetic and logical operation in that ALU. Whatever be the arithmetic operations and logical operations which microprocessor will perform, that all are covered in that unit, and that unit is named as ALU. So these 4 different arithmetic operations we are discussed earlier. Simultaneously this another logical operations also discussed. Now going to the today's lectures, and today we are discuss about the second content, that is the program status word, or it is also called as the flag register. So this is the block diagram of microprocessor 8085. Still we are covered the general purpose register B, C, D, H and L. This block we are completed. Again we again discuss about the accumulator and arithmetic and logical unit. So from this complete block diagram we are covered this block, accumulator, arithmetical logical unit and the buses which we are studying in the previous few lectures. Now going to the another block. Today we are discuss this block. That block is called as the flag. And if you observe that in flag, in bracket here given is the number is the 5. Previously whatever be the blocks we are studying, at in that block the number is given as a 8, like the B, C, D, H, even though in accumulator, even though in the arithmetic and logical unit. But in the flag number is given 5. The number 5 indicate that this flag having the 5 flip-flop, or this flag will store the 5 bit of information. This is also one of the register which will store the 5 bit of information. So let us go into that program status word or flag register. The another name is also given as the processor status word. This flag register is named by the program status word or processor status word. So it is also 8-bit register, but out of that 8-bit, only 5-bit will gives the particular status. That's why the number is given here, the 5. Getting? Because the only 5 flip-flop will gives the particular status instead of that 8. So that 5 flip-flops are here given as S, Z, AC, P and CF. This is the 8-bit register or 8-bit number we are considering, and in that 8-bit registers we are storing the 8-bit of information, but 5 flip-flop will give the particular status, and hence these are called as the program status word, or it is called as the processor status word. So this bit, first bit is assigned as a CF, and CF is stand for carry flag. Microprocessor MUP 8085 having 5 flip-flops, 5 flags. It's having 5 different flags, and first flag is named as the carry flag. Second flag is assigned as the auxiliary carry flag, and it is given by AC. It is designated by the term AC. While the third flag is assigned as the parity flag, and it is given by or designated by the letter P. Fourth flag is the 0 flag given by the letter Z, and sign flag is given by the letter S. So these are the 5 different flags are available with the microprocessor 8085, and this flag will give the particular status of the result. That's why this flag is called as the program status flag, or it is also called as the processor status word. So now one by one in sequence we know about how this flag can be used. So going to the first flag, that flag I assign as the carry flag. Here in that slide we are covered the information about the carry flag and auxiliary carry flag. So first we are going towards the carry flag. So what is the use of that carry flag, or what is the importance of that carry flag that we are now studying? So whenever microprocessor perform arithmetic operation of 2, 8/16-bit number, then this carry flag will shows the particular status. How it will show the particular status, that we are now discuss. Suppose we are consider one example of 2 8-bit numbers. I have considered this 2 8-bit number 92H and 85H, and I want to perform the addition of this 2 8-bit number. Arithmetic operation करना है, either it may be addition or it may be a subtraction. So suppose I have considered that I want to add this 2 8-bit number 92H and 85H. So first step is that we are converting that number into the binary form. So we are convert here 92H into the binary form. Similarly, the 85 are also converted into the binary representation. After that, microprocessor will add these two numbers with each other in the arithmetic and logical unit. ALU में ये दो numbers add होंगे. So while performing the addition of two 8-bit numbers, we are adding this two 8-bit number, and after adding this two 8-bit number, if the carry is generated, and if you are getting the carry, then your result may be a 9th bit. We are adding the addition of two 8-bit number. दो 8-bit number को add कर रहे हैं. अगर कैरी जनरेट होता है ये दोनों को ऐड करके, तो आपका रिजल्ट मैक्सिमम कितने बिट का रहेगा? 9th बिट का रह सकता है. सिमिलरली अगर हम 16 बिट का नंबर ऐड करते हैं, दो 16 बिट के नंबर को अगर ऐड करते हैं, तो मैक्सिमम रिजल्ट आपका कितना रह सकता है? 17th बिट रह सकता है. So here we are adding these two numbers, 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0, 1 plus 0, 1. Likewise, 1 plus 1, 0 and 1 carry is generated. Right? So, when this carry is generated, your result is your 9th bit result. If you are counting this total number, that number is your 9th bit number. So, this last 9th bit, that is 1, is copied into the carry flag. Whenever the microprocessor performs the addition of two 8-bit number, after addition of two 8-bit number, result is always stored in the accumulator that we are already discussed. So, this 8-bit result is stored in the accumulator, but this 9th bit, which is the carry bit, that is stored in the carry flag. So, whenever microprocessor will perform the addition or subtraction of two 8-bit number, whatever be the carry is generated or borrow is generated, after performing the addition of two 8-bit number or subtraction of two 8-bit number, that 9th bit is copied into the carry flag. It may be 0 or it may be 1. For this example, we are getting the carry is equal to 1. But if the carry is not generated, in such case carry flag is big, carry flag में 0 कॉपी होगा. यहाँ पे अभी 1 जनरेट हुआ है, that's why carry flag में 1 कॉपी होगा. But if the carry is not generated, in such case carry flag will indicate the status is equal to 0. So in this way, this carry flag is used for storing the carry bit into that particular flag. So that's why that is called as the carry flag. Going to the another flag, that is the auxiliary carry flag. So what is the difference between carry flag and auxiliary carry flag that we are discuss first. Carry flag में मैंने बताया कि after adding the two 8-bit number, whatever be the 9th bit is generated, that is copy into the carry flag. दो 8-bit number का addition करने के बाद लास्ट में जो 9th बिट का रिजल्ट अगर मिलता है आपका, वो बिट कॉपी होता है कैरी फ्लैग में. While in the auxiliary carry flag, whenever you are performing the addition of two 8-bit numbers, after adding the two 8-bit numbers, let us take this example here. We are adding these two 8-bit numbers, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, and here 1 plus 1, 0, carry 1. Auxiliary carry flag में after adding the 4 LSBs, if carry is generated, then that carry is copied into the auxiliary carry flag. That is the difference between carry flag and auxiliary carry flag. ऑक्सिलरी कैरी फ्लैग में 4 LSB ऐड होने के बाद अगर आपका कैरी जनरेट होता है, दैट बिट इज कॉपी इनटू द ऑक्सिलरी कैरी फ्लैग. व्हाइल इन द कैरी फ्लैग, आफ्टर एडिंग दिस 8 LSB, if the carry is generated, that is copy into the carry flag. Are you getting the difference between carry flag and auxiliary carry flag? In carry flag, after adding the 8-bit number, you are getting the 9th bit result, that is copy into the carry flag. But while in auxiliary carry flag, while performing the addition of two 8-bit or 16-bit number, after adding the 4 LSBs, if the carry is generated, that carry is copied into the auxiliary carry flag. So this is about the difference between carry flag and auxiliary carry flag. Simple carry flag में हमारा 8-bit का addition हो जाने के बाद whatever be the carry or borrow is generated, that is copied into the carry flag. While in the auxiliary carry flag, after addition of 4 LSBs or after subtraction of 4 LSBs, if the borrow is generated or if carry is generated, that is copied into the auxiliary carry flag. So these two different flags are there, and these two different flags will show their own status. Going to the another flag, that is the parity flag. So first we know about what is meant by parity. After that, going to the importance of that parity flag. we are discuss about the importance of parity flag. So let us know about what is meant by parity. Parity is nothing but, suppose one 8-bit number is given. In that 8-bit numbers, how many number of ones are present? That numbers is indicate their parity. Number of ones present in 8/16-bit number is known as the parity. ये जो complete 8-bit number दिया है, इस 8-bit number में कितने number of ones present है, that will show the parity of that particular number. अभी मैंने यहाँ पे 8-bit number consider किया है, you may be consider as a 16-bit number also. So just count here how many numbers are there. So I count here, this is the first number 1, then 2 and 3. In that 8-bit number, how many ones are there? 3 ones are there. So that's why 3 is the odd number, and hence this is called as the odd parity. If the number of ones in an 8-bit number is odd, then it is called as the odd parity. While if number of ones are even, this is the another example. In that example, number of ones are 1, 2, 3 and 4. Number of ones are 4 and 4 number is the even number. So that's why such number having the parity is the even parity. That parity is called as the even parity, and when even parity is there, in such case parity flag P is equal to 1. Parity flag will give the status P is equal to 1, and if the number of ones are odd, in such case parity flag will give the status P is equal to 0. Getting? Parity is nothing but only count the number of ones in that result or number, and depending upon the number of ones in that 8-bit number or 16-bit number, it will show the parity of that particular number, and this parity flag will indicate the status according to the number of ones present in that number. If it is the odd, then it is called as the odd parity, and in such case parity flag P is equal to 0. While for the even parity, parity flag will give the status P is equal to 1. So we are covered carry flag, auxiliary carry flag and parity flag. Going to the another flag that is called as the 0 flag. The name itself indicates that the 0 means, suppose our result, whatever be the results you are getting after addition of two 8-bit numbers or 16-bit numbers, if we are getting the result becomes 0, then this 0 flag will be activated. Depending upon the results you are obtained, according to that result, this 0 flag will give the particular status. So here I have write down, whenever the microprocessor perform arithmetic operation of two 8/16-bit numbers, then this 0 flag will give the particular status. So again consider here the two examples. Here we are considering the two 8-bit numbers that are the zeros, both are the 0 numbers, 00H and 00H. When we are adding these two 8-bit numbers with each other, I have getting the 0 result. All bits are 0. So if your result is 0, then 0 flag will give the status Z is equal to 1. रिजल्ट अगर आपका 0 रहता है तो उस केस में Z फ्लैग का स्टेटस रहेगा 1. While if your result is non-zero, यहाँ पे 2 बिट का एडिशन किया है. This is the another example. In that example, we are adding these two 8-bit numbers with each other, and our result is the non-zero. So when you are getting the non-zero result, in such case, Z flag will shows the status Z is equal to 0. Somewhat opposite, थोड़ा opposite है. रिजल्ट अगर 0 रहता है तो 1 दिखाता है और रिजल्ट अगर नॉन ज़ीरो रहता है तो आपको यहाँ पे स्टेटस 0 दिखाता है। गेटिंग? सो दिस इज अबाउट द ज़ीरो फ्लैग। लास्ट फ्लैग इज द साइन फ्लैग। सो लेट्स नो अबाउट द साइन फ्लैग। अभी तक हमने जितने भी फ्लैग्स देखे, स्टार्टिंग फ्रॉम कैरी फ्लैग, ऑक्सिलरी कैरी फ्लैग, पैरिटी एंड ज़ीरो फ्लैग. So here all we are performing the arithmetic operation, and in arithmetic operation whatever be the results you are getting, according to that flags will shows the particular status. So arithmetic operation हमारे साइन नंबर के भी हो सकते हैं और अनसाइन नंबर के भी हो सकते हैं. So if the microprocessor will perform arithmetic operation of two 8/16 bit sign binary number, then this sign flag will shows the particular status. मीन्स ये फ्लैग हमें कब स्टेटस शो करेगा, अगर हमारे जो गिवन नंबर्स है 8/16 बिट नंबर्स, वो अगर साइन बाइनरी नंबर्स है, साइन बाइनरी नंबर रहते हैं, उस केस में ये साइन फ्लैग पर्टिकुलर स्टेटस दिखाएगा. While if your two 8-bit numbers are the unsigned binary number, then this flag will never shows their particular status. सिर्फ साइन बाइनरी नंबर अगर रहते हैं दो और उन साइन बाइनरी नंबर्स का अगर हमें एडिशन करना है, इन सच केस दिस साइन फ्लैग विल गिव्स द स्टेटस. बट अगर अनसाइन नंबर्स आपके गिवन है तो अनसाइन नंबर का एडिशन और सब्ट्रैक्शन करते समय साइन फ्लैग कोई भी स्टेटस नहीं दिखाता है. ठीक है. सो अगेन आई हैव कंसिडर दिस टू 8-bit नंबर. सो साइन बाइनरी नंबर्स का अगर हमने एडिशन किया है और वो रिजल्ट अगर आपका पॉजिटिव है, देन साइन फ्लैग विल शोज द s इज इक्वल टू 1. अब आपका डिजिटल सर्किट में साइन एंड अनसाइन नंबर्स का आपने एडिशन सब्ट्रैक्शन किया है. आपको पता है कि साइन नंबर किस तरीके से आइडेंटिफाई किया जाता है कि वेदर इट इज़ द पॉजिटिव नंबर और इट इज़ द नेगेटिव नंबर. दैट कैन बी शोन बाय यूजिंग द लास्ट बिट. जो भी लास्ट बिट रहता है 8 बिट का, उसका लास्ट HSB जो है, HSB को 8 बिट को आइडेंटिफाई करके हम आइडेंटिफाई करते हैं कि वेदर योर नंबर इज द पॉजिटिव नंबर और नेगेटिव नंबर. सो हियर सपोज you are adding the two 8-bit numbers, and if you are after adding the two 8-bit number your result is the positive number, then sign flag is become s is equal to 1. While after adding the two 8-bit number your result is the negative number, then sign flag is equal to the 0. So in this way these all flags are work according to the operation performed in the ALU, whatever be the arithmetic operations we are performed, and according to their results these all flags will give the particular status. So this is one of the important